Now we shall be discussing two examples. Both the examples will be covering all the three scenarios. Three scenarios which say that Fn equal to theta gn, Fn equal to big O of gn, and Fn equal to omega g. The first example, I say that Fn equal to n cube and gn equal to 2 to the power n. Now, as shown in the table, what is the scenario? This is n cube 0, 1, 8, 27, 64 and so on. This is n cube, that is Fn. And what is the second row? It is gn, that is 2 to the power n. That is 1, 2, 4, 8, 16, 32 and so on. Now, if I ask you whether gn is the lower bound of Fn or gn is the upper bound of Fn, if you analyze, what is the scenario? I say that when n equal to 0, Fn is smaller than gn. Fn is smaller. Fine. Similarly, at n equal to 1, what is the scenario? Fn is smaller than gn. But what happens at n equal to 2? It is vice versa. It says that Fn has got to be greater than g. Right? Till what point I can say that till n equal to 9, the same case continues. That is, f remains greater than g. 729 is greater than 500. So you can say there are two cuts between the graphs of Fn and gn. When I draw it, Fn is smaller than gn when n equal to 0. Fn is starting out from 0 and gn is starting out from 1. But when n comes out to be equal to 1, again the same scenario, that is Fn is smaller and gn is larger. Okay, this is g, this is f. Okay? But when n comes out to be equal to 2, then what happens? F comes out to be greater than g. This is f and this is g. Why so? Because when n equal to 3, f is coming out to be, Fn is generating 27 and gn is generating the figure 8. This scenario continues, that is the scenario which I am talking is that Fn is greater than gn. This scenario continues till this point. Okay? That is, this Fn is greater than gn, this f is going on and this g is going on. Sorry. This g is going on and this f is going on. This condition, that is f greater than g. Okay, f greater than g. This scenario is continued till n equal to 9. But when n comes out to be equal to 10, then what happens? As you can see, it gets out to be vice versa. Okay, the scenario, it gets on to be the other way around. It says that when n equal to 10, then Fn comes out to be 1000 and gn comes out to be 1024, which says that Fn is coming out to be smaller than gn. And what about at n equal to 11? It says that Fn is generating 1331 and gn is generating 2048. So you can say a large gap. Fine. So you can say that after this figure, after when now n gets out to be equal to 12 and gets out to be equal to 13, what the scenario will be maintained? Which scenario will be maintained? Always gn will be greater than Fn. Always. So you can say which definition is this pair of functions? It is with which conditions are being satisfied out of the three functions. Okay? What can you say? That after n equal to 10, always Fn will be smaller and gn will be larger. Okay? Fn will be smaller and gn will be larger after n gets out to be greater than equal to 10. So, what can you say? That gn is the upper bound. Gn is the upper bound, and which notation is used for defining the upper bound? That is big O. So, in terms of asymptotic notations, if Fn is if Fn is smaller than gn, gn is greater than Fn, then in terms of asymptotic notation, how will you represent? That gn being upper bound, Fn is equal to big O of gn. That is, gn is the upper bound of gn is getting out to be greater than Fn always till infinity. And if you analyze, can you say that if Fn is smaller than gn, then gn will be greater than Fn. Right? Gn will be greater than Fn. That is, g will be representing the upper bound for, G will be representing the upper bound for f. If Fn is representing representing the lower bound of G, then Gn will be representing the upper bound of F. So if Fn equal to big O of Gn, then I can also conclude that Gn is omega of F. Fine. Gn greater, this is G, this is F. Gn is greater than Fn, so Fn equal to big O of Gn and Gn equal to omega of F. This property of if F equal to big O of G, then G equal to omega of F, this criteria is called the transitive symmetry. Transitive symmetry of the asymptotic notations. Fine. Now, if you have a look at the other example, the next example we say that Fn equal to 2 to the power root n log n. Similarly, Gn equal to 3 into n to the power root n. Now, since directly comparing these two functions is quite complicated, we cannot say that which one is greater and which one will come out to be smaller than the other. So, to simplify the scenario, what we do? We take the log on both sides. Why we take log? We know that if F will be greater than G, the log of F will be greater than log of G. Okay. So it means in order to compare both, I can also take log on both ends and then compare it. So taking log on both sides, I say when I take the log of Fn, it says 2 to the power root n log n. Now if we implement the formula of a log, then it will say power is coming up, right? And then we are taking up the log of the base which is 2, right? Since the base is also 2 and we are taking the log of 2, and log 2 to the base 2 is 1 always, because it is same as the base, fine? So what will be the result of this scenario? It will be root n into log n to the base 2, right? This is the log of Fn, and when we take the log of Gn, then as you have done in your schools, that what is if two functions are getting multiplied, for example one of the function is m and the other is n, if we take the log of mn, then what is the result? Log m plus log n. So implementing that particular formula over here, if this is m and this is n, sorry, this one, okay, this one is n to the power root n is n and 3 is n, then when we shall be taking log, it will say that log m, that is log 3 plus log n. Okay, and when we shall be taking the log of n to the power root n, then what will be which formula will be implemented? It says that if we are taking the log of n to the power m, then what is the scenario? The power will be coming up, power will be multiplying the log n. This formula is getting implemented over here, and this power will be multiplying log n. Fine. So as you can see, this is a small constant, 1.73, okay, and this is root n log n, log 3 to the base 2 plus root n log n. This is what Gn is generating on taking the log, and root n log n, this is what Fn is generating on taking the log. And if you have a look, there is a constant difference between these both functions, and I can take the values of C1 and C2 such that this Gn, for example, if I take up C1 as half, okay, if we take up C1 as half, that is, this is Cgn, okay, then I take C1 equal to half, then this will always be lesser than this one, right? Because I am multiplying it with half, fine. And if I take up C2 as 2, which will multiply this with 2, then what will be the scenario? This will always be the upper bound of F. Now, for one of the constant, it is proving to be the lower bound, and for the other constant, it is proving to be the upper bound. It means what is the scenario? Which condition? The definition of which of the asymptotic notations is this scenario following? It says that if Gn is proving to be upper bound for one of the constants and lower bound for the other constant, then we can conclude that Fn equal to theta of G. So it means if Fn equal to 2 to the power root n log n and Gn equal to 3 into n to the power root n, then what is the relation between Fn and Gn? Fn is equal to theta of G. Fine. We shall be discussing more examples, but since time is almost over now, so we shall be discussing this tomorrow.